வணக்கம். Welcome to YouTube channel. The last class we have seen lesson 1 real analysis. We have seen the topic sequence. Next, a very much interesting topic, that is the limit of the sequence. In particular, limit superior and limit infimum, that is upper limit, lower limit. Last class we have discussed sequence, upper bounds, lower bound, least upper bound, greatest lower bound, and then bounded sequence. So last class we have discussed about definitions and we discussed problems. Now we are going to see the limit of a sequence. Any sequence we take only unique limit, that is L. Suppose the oscillate sequence, that is divergent. The last class we have seen 1 minus 1, 1 minus 1, that is oscillates, but bounded, but not convergent, because two limits, one either 1 and minus 1. But sequence have one limit, unique limit only. Suppose we take one sequence, we take subsequential. We take the subsequence. We take the subsequence. We take the limiter. We are getting limit supremum and limit infimum. Very important topic. Everyone, we have studied this topic in MSc Mathematics. Even though I recall again the definitions and the problem. So we will see now. Please watch the full video. We'll give the response. Moreover, I have to thank my subscribers. I have to get monetization, I think. Monetization. In future, to upload videos like this, mathematics videos, national level competitive examinations, the conducting, the state board level and the national level. The lot of examinations are there in mathematics subject. So this video is some useful, not 100%. I am not saying 100%. Some idea. I give the full assurance for that. So subscribe this Math K channel. But subscribe, that is your wish. Subscribe or not, I won't compel you. But why I am asking subscribe? Because I get the monetization from the YouTube channel. So that's why I am asking the subscribe this channel. Again I am telling you, I am not compelling you, because your wish. So we are entering the topic now. We will see the definition and problems in limit supremum and limit infimum. Okay, let us see. Lesson 2. Now we are going to discuss about limit superior and limit infimum, inferior, limit inferior. So before that, what is the limit of a sequence? We know very well what is the limit of a sequence. We take the limit of the given sequence, we get the finite value. So there is a limit of that sequence. We know the well-known the Bolzano-Vices theorem. Every bounded sequence has a limit point. We know that. Next, what about the convergent? What is the meaning of convergent? A sequence having the limit unique. Then you can say it is a convergent sequence. So that's why the limit of a convergent sequence is unique. Am I right? So a bounded sequence is convergent if and only if it has unique limit point only. Every bounded sequence has a convergent subsequence. Very important result. We know already, we have studied this in MS level. Again I am telling, every bounded sequence has a convergent subsequence. What about the Bolzano-Vices theorem says? Every bounded sequence has a limit point. Okay. Now, what is the definition of limit superior of the sequence, or otherwise we call limit superior? There is limit SUP using here limit superior of UN, or limit superior of UN. These are all the give the same meaning. I take this sequence be a bounded sequence of real numbers. Bounded sequence means lower bound, upper bound. The last class we have seen the greatest subsequence, the subsequential. The limit of this UN sequence is said to be a limit superior. The least subsequential, the limit of UN is said to be a limit inferior, or that is limit infimum of UN, or limit inferior of the sequence UN, or using this notation which is denoted by like this, limit inferior, which is denoted by limit superior. So this is denoted by like this, limit superior, which is denoted by like this, limit inferior. Otherwise, limit supremum of UN, limit infimum of UN. Just note on this. Then important theorem 1. Everyone you should know about this. A bounded sequence. I take the sequence, a bounded sequence is convergent if and only if limit supremum of UN, which is equal to, should be equal to limit infimum of UN. Then only you can say it's a convergent. So a bounded sequence is convergent. The limit supremum equal to limit infimum. Every convergent sequence bounded, we know very well, right? Every convergent sequence bounded. For example, I take this sequence, well-known sequence, that is 1 by 2, 1 by 3 up to 0. It's a convergent sequence. What is the limit of this one? 0. So it's a convergent sequence. Hence it's a bounded. But converse need not be true. Bounded sequence need not be convergent, but convergent sequence is bounded. Now first problems. Problem 1. We have to find out limit supremum of the given sequence and limit infimum of the given sequence. The given sequence is minus 1 power n into 1 plus 1 by n, where n greater than or equal to 1. Just I am substituting values for n equal to 1, I am getting the first term, n equal to 2, then next third, 4, 5, 6. See here, suppose n 1, 3, 5, that is odd, that is 2m plus 1, I am right. I take n equal to 2m plus 1, give so odd. Suppose n equal to 2m, we are getting only the even. So you have to take two subsequence. We get the limit supremum and the infimum. So after simplifying, we are getting minus 2 here, 3 by 2 extra, minus 4 by 3, then 5 by 4, minus 6 by 5, and so on. We take a subsequential, already un we know. I take un1, un which is equal to un1 union un2. Two subsequence. I take union, I am getting the original sequence un. So I consider like this un1 only negative. When give the n value odd, we are getting the negative terms. Suppose when give the n value even numbers, we are getting positive terms. Now I take the limit again. We know very well this one. I take the limit nth term of the sequence minus 1 plus 1 by n1. I take n. Why I take n1 means because a subsequence un, the subsequence un1. So applying this limit minus 1. So 1 by infinity 0. We know very well. So minus 1. So minus 1 is called the limit infimum of the given sequence. Next subsequence un2. From the un I take the sequence 3 by 2, 5 by 4 is positive terms of this sequence. I take the limit n2 tends to infinity un2, that is 1 plus 1 by n, 1 plus 1 by infinity 0, 1 plus 0 1. So this is the limit supremum. Now we got the limit infimum, limit supremum. So minus 1 1. Second one is a very interesting one. The same, you have to find out the limit supremum and infimum of the given sequence n by 4 minus, we know this, the greatest integer function, greatest, otherwise we know about the step function. The least positive integer less than or equal to this one. We know about this one. Now give the n values 1 by 4, then 1 by 4. So 1 by 4, 0.25. According to the greatest integer function, 0. So 1 by 4 only. Next, give the n value 2, 2 by 4 minus 2 by 4, that is after simplification 1 by 2. Here 0.5, that is 0 again. So only 2 by 4. Next, give the value 3, 3 by 4, 0.75, still 0, the least positive integer 0, so 3 by 4. Next, give the n value 4, 4 by 4, 4 by 4, this is we know very well 0. Next, give the n value 5, here 5 by 4, 5 by 4, this is the least positive integer 1, so 5 by 4 minus 1. Next, give the 6, 7, 8, like this. We are getting the terms like this one. After simplifying 1 by 4, then 1 by 2, then 3 by 4, next 0, 5 by 4 minus 1. After simplifying, 3 gets cancelled, 3 by 2 minus 1, next 7 by 4 minus 1, then this becomes 0, so and so on. So finally what we are getting, 1 by 4, 1 by 2, 3 by 4, 0, 1 by 4, 1 by 2, 3 by 4, again 0, 1 by 4, so repetitions, 1 by 4, 1 by 2, this is a subsequence, that's all, over. So take here also well known, what is the limit supremum of this sequence? Everyone immediately you can say 3 by 4 immediately, limit supremum. So what is the limit infimum? That is 0. Right, 0 is the limit infimum of the given sequence. So answer is supremum is 3 by 4 of the given sequence. Limit infimum of the given sequence is 0. Next, a third one. I take this sequence, give the n values like this 1, 2, 3. We know these steps are well known. After simplification, we are getting these terms. We take the subsequence like this 1, 2, 4, 6, 8, 10, up to this goes to infinity. I take like 1 by 3, 1 by 5, that is the rational terms I am collecting from this sequence, 1 by 3, 1 by 5, 1 by 7, 1 by 9, this goes to 0, am I right? So well known, this is the limit supremum, which is limit infimum. So limit superior of this function is infinity, inferior, that is infimum of the given sequence 0. So this is our final answer. I think you are understanding clearly. The fourth problem, very interesting one, cos n pi by 4. This question asked in several times in competitive examination. Cos n by 4 whole power minus 1 whole power n, give the values for n, 1, 2, 3 and so on. We are getting this, you know, this every terms 1, 2, 3, 4, 5. Cos pi by 4, that is cos 45, 1 by root 2 power minus 1, cos pi by 2, cos pi by 2 value a small correction, cos pi by 2, pi by 2, cos pi by 2, 0. because cos 0 1, so cos pi by 2 cos 90 0. Next cos 3 by 4, we know that minus 1 by root 2 or minus 1. Then next term 4 gets cancelled, cos pi, the cos pi value minus 1, already I am telling this result, cos n pi equal to minus 1 whole power n, when cos pi minus 1 cos 2 pi plus 1, where n is odd integer, positive integer, we are getting minus 1. Suppose n is the even positive integer, we are getting the plus 1. So that's why we are getting the minus 1, n minus 1 by 2 power minus 1. See, alternating, that is see the power, alternating power, that is minus 1 plus 1 minus 1 plus 1 minus 1 plus 1. So after simplifying this, what you are getting, root 2 1 minus root 2 minus 1 minus root 2 minus 1 root 2 1. We have to take the subsequence positive terms and negative terms of the subsequence. After taking limit, we are getting the limit supremum of given sequence is root 2, limit infimum of the given sequence is minus root 2, very clearly, am I right? So root 2 is here limit supremum minus root 2. So this is a limit infimum. The next, the last problem, fifth one. Please note down this one. Fifth one also very important problem. This question asked in T or B and set exam level, state level eligibility test. This question asked alpha n, so given sequence n square sin square n pi by 2 is a sequence of real numbers. We have to find out limit infimum and limit supremum. So this is our question. So give the values 1 2 3 like this. Before giving the values, we take the subsequence like this, alpha where n equal to m, there is a full and full even, where give the m value, we are getting the even terms. Instead of n, I am substituting 2m. So 2m whole square, 2m power whole square, that is 4m square sin square, instead of n 2m pi by 2, 2 gets cancelled, sin square m pi, where m is positive integer. So whatever it is, we know this very well, this result sin n pi equal to 0. So when n is even, that is one of the subsequence, taking the limit 0, because the null sequence 0. So because of this, 2m plus 1, when n is odd, we are getting like this, am I right? Instead of n 2m 2m plus 1 whole square sin square, instead of n 2m plus 1 pi by 2. Here we are getting the 1, whatever is the m positive value, 1 2 3 1. Suppose for example 1, I am going to take a 3 by 2, whatever it is, 1 minus 1 1 minus 1, because square is there. So negative 1 become positive 1. So whatever it is, we are getting the 1. We are taking the limit. Here well known, the 0 is a limit infimum. Am I right? Please note down this one. I think are you able to understand? the limit, that is limit infimum. What about the limit supremum of this one? Infinity. Just now you have seen m goes to infinity, this subsequence goes to infinity. That is limit supremum of the given sequence infinity. Limit infimum of the given sequence is 0. So this is our final answer. Limit superior of the alpha n sequence is infinity, and limit infimum alpha n equal to 0. So thanks for watching video and your support. So subscribe this Math K YouTube channel. Is there any mistake or is there any command? Please come and send the message. Is there any mistake? By mistake, definitely I will correct. So thanks a lot. Thank you very much. Nandri.